Hello, grade 10. Today we're going to start a new topic about electricity and magnetism, okay? So this is the next chapter and we are going to study very deep about electricity and magnetism. Okay, in this lesson I'm going to focus on what is electricity. So I ask you, what comes to your mind when I ask you what's electricity? What goes to your mind? Tell me. Your cell phone, probably, that you love it. Yeah, your computer. So all your devices just work because we receive electricity. If you watch the previous video, you can have an idea of how electricity is produced and comes to our house. Electricity, if we talk about the physics behind, it's all the phenomena caused by positive and negative charges. This electricity, it's not new, okay? Actually, it was discovered a long time ago by the Greek philosopher Thales de Miletus, about 600 years before Christ era. So it's a long time ago. Which experiment he did? He observed when he take a piece of yellow amber that watching in Jurassic Park, that one, and rub it against wood. Okay, what happens? The amber has the ability to attract small objects. So when it rub these two, it has the ability to attract other objects. Okay, so I didn't have a picture about the amber attracting, but here, just to illustrate, the wool is like the hair of the cat, and the amber is all this material. So when they are rubbed, they attract, okay? So create some electricity that attract each other. So it was discovered by Thales de Miletus a long time ago. Also, another scientist called William Joubert in the 16th century observed that other substance has similar properties of the yellow amber. So he observed not just the yellow amber, but other substance has the same property. For example, glass, resin, or sulfur. All of them can attract small objects when they are rubbed. So they are called electrically charged. So if you do the same experiment using glass or resin or sulfur, you got the same effect, okay? So the other objects get attracted when they are rubbed. Electrically charged objects can either attract or also repel one another, okay? So this is for attraction or repel. Benjamin Franklin in the 18th century, identified two types of electricity, a negative and positive charge. By this experiment, when they rub two glass together, they repel each other. So if you try to rub two glass rods, they are going to repel each other. But if you rub a glass rod and a plastic ruler, they are going to attract each other. Okay, so this was identified that Benjamin Franklin just said there is some negative and positive charge related to this, but of course we didn't know yet which one was that. So where this negative and positive charge come from? Where this come from? So the negative and positive charge comes from where? From the subparticles of the atoms. What are the subparticles of the atom? The proton, neutron, electron. Yeah, so these are the three subparticles of an atom. So proton is a subparticle. Neutron, where are they? In the So proton and neutron are in the nucleus. Oops, let me erase, it's too dark. So they are in the nucleus. So it was after we discovered about the atom. Now we know that the electrical charge is related to the property of protons and electrons. Why? Because they have charge. What is the charge of the protons? The charge is positive. So protons have positive charge. What about the electrons? Electrons have negative charge. So electrons, negative charge. What about the neutral? The neutral has the name because it's neutral. There is no charge at all. Because neutron has no charge at all, but proton is positively charged, what is the charge of the nucleus? The charge of the nucleus is positive. Very good. So nucleus has positive charge. Why? Because nucleus has protons and neutrons. If a neutron doesn't have any charge, the only charge the nucleus will have would be the proton. Okay? So where this electricity comes from? From the subparticles of the atom. Which subparticles? Protons, electrons, and neutron. Because neutron has no charge at all, basically we are just talking about protons and electrons that has relation with electricity. Now, how do I know a body is charged? It's charged by negative or positive charge, depending on the number of electrons and protons this body has. Okay, so we just can say the protons is negative, the body is negative. Why? There is more electrons than protons. So when I have more electrons than protons, I say my body is negatively charged. And when my body is positively charged, what do I have more? I have more protons than electrons. And when I say my body is neutral, when I have both are the same. So electrons equals to protons. So let's do an example. We are going back a little bit for chemistry, but this is really important for you to understand, okay? So let's say about this element, sodium. From the periodic table, we get this number. Remember, we have two numbers, atomic number and mass number. This is my atomic number. From my atomic number, I know the number of protons and electrons if it's neutral. So here is a diagram. Here I know from sodium, from the periodic table, that it has 11 protons in the nucleus. I'm not worried about the neutrons, okay, because I'm talking about charge. That's why I'm not putting neutrons here. I'm just saying about protons. So I know I have 11 protons in the nucleus. These protons are positive or negative? Positive. So by the number I have 11 positive charge. What about the electrons? How many electrons do I have here? So the same from the periodic table. Remember, atomic number is the same as the proton number and is the same as the electron number. Remember this a long time ago. So if I have 11 protons, I also have 11 electrons. Where are the electrons? In the electrosphere. Remember the rule? The first shell, I can put just 2, so 1, 2. In the second shell, I can put 8, so 1, 2, 3, 4, 5, 6, 7, and 8. And so 8 plus 2, 10. I have one more here. I put in red just to emphasize that this is the valence electron, okay? So this is the valence electron. So in this case, I have 11 protons and 11 electrons. Where do I get this information? From periodic table. Okay, so this is a neutral body, a neutral atom of sodium. Okay, but if you remember chemistry, this element is stable like that? No. Why? It doesn't have 8 electrons in the last shell. So what's gonna happen for this to be stable? It's gonna lose this electron. When it loses this one, the next shell is gonna contain 8 electrons. Then it's gonna stay stable. So let's pretend. So in this case, my atom is neutral, but it's gonna lose. So I have 11 protons, 11 electrons. Now, if I lose this electron, what's gonna happen? I lose my last shell because I lost my valence electron. Now, how many protons I have here? Did I change anything in the nucleus? No, I didn't change anything. So how many protons do I have? 11. How many electrons do I have now? I lost one. So how many I have? 10. So if I count, I have 2 here, 2 in the first one, 1, 2, and 8 here. 1, 2, 3, 4, 5, 6, 7, 8 electrons. So I have 10 electrons. What do I have more? My atom now is positively charged or negatively charged? How do I know? It has more protons than electrons, so it has more positive than negative. So it is positively charged. How do I represent? By an ion, remember? So this is sodium, positively charged. Just one because it lost just one. So it has, in the balance, it has one more positive charge than one negative charge. That's why I have just one positive. Okay, so my body here is an example of a positively charged element. Now, let's do the same, but using another element, the chlorine. So chlorine, what do I know in the periodic table? From the periodic table, it has 17 electrons and 17 protons. So I'm going to represent in a diagram. I have here 17 protons. What's the charge of the protons again? Protons are positive. Good. And how many electrons I have? So let's count. 1, 2 in the first shell. 1, 2, 3, 4, 5, 6, 7, 8 in the second one. So I have 10 up to here. Now 1, 2, 3, 4, 5, 6, 7. So I have 17 electrons. This is neutral. Why? I have protons. How many? 17. Electrons? Also 17. So my positive charge is the same. My positive charge is the same as my negative charge. So it is neutral. But it is stable like that. How many electrons it has in the last shell? 7. It is stable? No. To be stable, how many electrons the atom wants? 8. Remember the octet rule. Now, this electron needs to receive one electron, sorry. So it needs to receive one electron here to be with 8. Now, does anything change in the proton number? No. How many protons do I have? Still have 17. But now how many electrons do I have? I had 17 before, Now I have 18. So what do I have more? Protons or electrons? Electrons. So I have more electrons than protons. So it is negatively charged or positively charged? Negatively charged. Very good. And how do I represent it? By writing an anion. Remember? So chlorine is one negative charge because it received one electron. Okay? So these are two examples of one negative and one positively charged body. And they fit very well. For example, for sodium and chlorine, they are the perfect pair. Okay? Because one wants to donate, one wants to receive one electron. Okay, now let's go back to physics, but as you see in science, everything is related. Okay, so if you don't understand that one, I'm gonna post more videos for you to remember that concept. Okay, so now in chemistry we were just counting, okay, the number of electrons. But in physics we're gonna measure. How gonna measure? Each proton or each electron has a charge. How do I measure this charge? By Coulomb. So one electron or one proton has 1.602 times 10 to the power of minus 19 Coulomb. So Coulomb is the unit of measure for electrical charge. So when we are going to work with charge, we are going to work with this unit, 1 Coulomb. 1 Coulomb means is the charge of 6.25 times 10 to the power of 18 electrons of protons. So if I measure the charge of 6.25 times 10 to the power of 18 electrons or protons, I have 1 Coulomb. And how do I measure the electrical force? So electrical force is how much two bodies attract or repel each other. How do I know? Just the law of conservation of matter also applies here, okay? Here I call law of conservation of charge. Electrical charge can neither be created nor destroyed. They can only be transferred, okay? So the same for energy. Charge cannot be created or destroyed, can only be transferred. And how do I know this transfer? If I have two positive charge or two negative charge, what's going to happen between them? They are going to repel. So if I have like signs, so if I have the same sign, they are going to repel each other. And what happens if I have two charges that are opposite? So if I have one positive and one negative charge, what's going to happen? So from opposite sides, what's going to happen? They're going to attract. Okay, so it's really important concept. If I have two signs that are the same, they're going to repel. If I have two signs that are opposite, they're going to attract. Okay, and how do I measure the charge? How much? By the Coulomb. So one electron or one proton has 1.602 times 10 to the power of 9 minus 19 Coulomb. Just one electron or one proton. Okay, so now I'm gonna talk about conductors and insulators. So charge, what's charge? Consists of creating an imbalance. Charge is basically when you transfer the electricity from one side to another, okay? From one object to another. So when you plug in your cell phone or your computer in the outlet, you are transferring charge from the outlet or from your electrical current from your home or your school, transfer to your device. Okay, so you are transferring from your energy source to your device. So charging is when, and how do I transfer? Because there is an imbalance. I have less here, less in my cell phone and more from my house, for example. So most objects are electronically neutral. What does that mean? That the number of protons, positive, is the same as the number of electrons. But that's not always the case, okay? By transferring electrons from one atom to another, some objects acquire a charge. So if I transfer electrons, I'm gonna be negatively charged. If I transfer protons, I'm gonna be positive charge. The overall is gonna be neutral. Okay, so some substances make this transfer easier and some not so easier. So the objects depend on how objects receive electrical charge. Conductors are substances that permits the free flow of electrical charge. Okay, so when I have a metal, for example, I can conduct electricity very well. So I allow a free flow of electrical charge. For example, metals are very good, or electrolytic solutions. What about semiconductors? Semiconductors, as the name said, they have variable conductivity. They depend on different factors, okay? So they are, for example, the same metals. And insulator are substance that doesn't allow the free flow of electrical charge. So that stops the flow. They are the nomads. So I'm going to explore each of them now, okay? So what are conductors? They permit the free flow of electrical charge. They are the metals and the electrolytic solutions. For example, here, have you ever done this experiment before? This is called Van de Graaff generator. What happens here? The charge that we got from the generator when it touched it, so the generator, the Van de Graaff generator, is giving some charge. When I touch it, this charge moves through my body. And then, why can I see in my hair? Because if I'm receiving this charge, my hair is trying to go far away. They are repelling each other. So hairs move as far away from one another possible. Okay, because they are receiving this charge from the generator. Okay, so I create electrical current inside my body. And this is not like damage because we have electrical current in our body. Another one that we talked before is the electrolytic solutions. Remember we had this experiment, or we just talked about it in class. When I put ethanol in a solution, it doesn't conduct electricity. But if I put, for example, KCl, it conducts, so it turn on the light. Or if I put acetic acid solution, I also conduct, but it's not so powerful. Why does this happen? Because I create ions. For ethanol, my molecules doesn't dissociate, remember? Doesn't dissociate, so I don't create ions. But when I put KCl, the K separates from the Cl. So we create charge, we create ion, K plus and Cl minus. So if I create charge, positive and negative charge, what's gonna happen? The positive ions goes toward the negative, remember? The different charge moves toward. So the positive are going to the negative electrode here. What about the positive, the K? The negative. The negative, the Cl, goes to the positive electrode. So the negative goes to the positive. Now I create a current because I'm creating a flow of electron. In the first one, for ethanol, I didn't create, okay? So I didn't turn on. But here, my flow of electrons, it's create a current. They are moving. For acetic acid solution, it's happened just a little bit because not all the molecules are dissociated. So some molecules becomes the same. It doesn't create the ion, doesn't create the charge. So just a few ions, it's moving the positive to the negative and the negative towards the positive. So these are good examples of conductors. So they are conducting electricity. What about semiconductor? So semiconductor, they have variable conductivity depending on different factors. They are the metalloids in our periodic table. Okay, what are the properties of metalloids? They have both metal and no metal properties. So they have both properties. So they behave sometimes with some as metals, sometimes as no metals. So sometimes they are good, sometimes they are bad conductor of electricity. So it depends on the answer that they are receiving, on the sign they are receiving, depends on how they are going to behave. This is very useful for electric circuits, okay, because sometimes in the electric circuits I need to conduct electricity, sometimes I don't, so it depends, okay? So we use semiconductor materials to control the flow of electrons. So I need these materials that I can control to control the flow of electrons by controlling the current. So in electric circuits, I need this kind of material to control how my flow of electrons, how my current is gonna happen, okay, according to what I need. Okay, now what about insulators? So insulators that they impede the free flow of electrical charge, so it doesn't allow me to have electrical charge. They are the non-metals in my periodic table. So when an insulator is charged, the charge do not move, so they remains stopped. Why? Because the electrons are hold tightly to their valence electrons, make it difficult for the electron to leave the atom. As you can see, for example, the family 7, they don't want to lose their atoms, their electrons, because they have 7 electrons in the last shell. So the electrons are highly attached. So say they are tightly to their valence electrons. It's very hard to remove one electron from them. Some examples of insulators, for example, plastic, glass, paper, ceramics, rubber, silk, even air. They are bad conductors of electricity. I'm not going deep about the components of them, but they are basically made of no metals, okay, of substance of these no metals of the periodic table. So they don't conduct electricity very well. Okay, now how do I represent an electrical field? Electrical field is an area on which electrical force or a charged body can act on another charged body. How do I represent them? An electrically charged body placed near another charged body is subject to an electrical force. This force can act at a distance. So sometimes I conduct electricity even though I'm not touching this. Just for some space, I already conduct. Electrical fields are invisible, so we cannot see, but we can represent them by electrical field lines. So I can represent them by electrical field lines. But there is a rule, okay, a convention. When I have a positive charge, by convention, I draw these field lines away from my positive charge. So if I have a positive charge, you draw like that. You draw the arrows away, moving away from the positive charge. When I have a negative charge, I represent it towards. So my field lines points toward my negative charge. Okay, so it's like from outside to inside. So it's attracting the negative, I represent by the arrow going toward the negative charge. Okay, so this is a convention. Okay, so if I have a positive charge, I represent the arrows by point out, moving away. If I have a negative charge, I point towards that charge. What happens if I have two close by, for example? Here I have one positive and one negative. By convention, my positive is moving away, right? So it's moving away. So going away. But my negative is moving toward. So toward. So this one that's moving away is going toward a negative charge. What happens if I have two positive? So they are going to repel. So they are going to move away. Both sides moving away. So it's very hard to put them together because they are repelling each other. Okay, so this one also show how easy it is to keep different charges close by and the same charge not attract at all. So the field as it strongest near the charge. So near the charge, I have the strongest field. So the lines around there are close together. So close to the charge, I have the highest field. Okay, I guess it's a lot of information. Okay, you can watch this video again if you want. And please, if you have any question, send me an email and answer the questions in the form. Okay, that's it for today. For the next lesson, we are going to continue this topic. Thank you so much, guys.